Good morning, sir. मनीष जी सब रेडी है, शुरू कर दे मनीष। मनीष, डॉक्टर मनीष
हाँ कर दो डॉक्टर साहब।
शुरू कर दे। सर भी ज्वाइन किया है लग रहा है। तो सर ठीक है। सर भी स्टार्ट। गुड इवनिंग अरुण सर, देशमुख सर।
Good evening to sir. Good
हाँ
evening to all. Yeah.
सर, actually 56 participant has joined. Usually sir 90 up to 92, 95 up to 90, more than 90 participants used to participate. So I think they will join in between, sir. I think we can start, sir.
Yes.
So let me introduce you, sir, for today, sir. So good evening, everyone. A very warm welcome to all the participants on day 8. And today we will be we will be focusing on efficient water management in maize. So we will be dealing with effective irrigation and fertigation practices. They will help in improving the water use efficiency. So today our distinguished speaker is Mr. Arun Desmukh, Deputy Director General, Deputy General Manager of strategic demonstration project, head agronomy or via precision agriculture. In short form, the SIR's organization is also known as NEPTAFIM, and sir will explain more about NEPTAFIM actually and what they are doing. Sir, you can explain a bit about NEPTAFIM in the this one, sir, in your intro. And Mr. Desmukh is a leading expert in precision irrigation, fertigation management, and sustainable crop production. Sir will deliver his lecture on irrigation and fertigation management in Maize for improving productivity and profitability. So, on behalf of all the participants, sir, I warmly welcome you, sir, to deliver the lecture, sir. Over to you, sir.
Okay, thank you. Let me share my presentation first, and then I will start. Okay.
Yes,
Yeah. Whether my presentation is visible?
yes, sir. Slide mode में हो जाए तो ठीक है, sir.
Yes.
हाँ.
Now it is in the presentation mode, right?
Yes, sir. Yes, sir.
Am I audible?
Very much, sir.
Okay. So, good evening to all. I'm very much thankful to the Indian Institute of Maize Research from the Indian Council of Agriculture Research for giving me an opportunity to have the presentation on irrigation and fertigation management for increasing the maize productivity and profitability to all of you who have participated. I extend my warm welcome to each and everybody who have participated. See, firstly, my introduction has been given, but I will introduce myself a bit. Actually, I passed Master of Technology from Indian Institute of Technology, Kharagpur in West Bengal in year 1987. Actually, I passed in year 1986, December 86. I started my job as a scientist in Vasantara Sugar Institute. I was heading the agriculture engineering department, and thereafter I was there in the institute for long 28 years. That time I was head of the department and principal scientist. I was involved in research, development, extension, training, and teaching activities related to irrigation water management and mechanization, especially for the sugarcane that time. Thereafter, I have joined the Irrigation Irrigation India Private Limited, and now I'm working as a deputy general manager for the sugarcane projects, as well as heading the agronomy department for the central and north India. Basically, my job profile is in three parts. One is the agronomical research, development, and extension activities. That's one. Second is we are converting certain lift irrigation projects into drip irrigation, that is automated drip irrigation. And third is especially for the conducting the actually webinars, seminars, conferences, the farmer meetings, and everything actually for the extension purpose. So today's topic basically is about the maize. As we know all, the maize is an important crop. Globally, it ranks third after wheat and rice. It is highly adaptable to various climatic conditions, as well as it has a very high production potential. It has many uses like food, animal feed, and industrial products like starch, alcohol, ethanol, plastics, etc. So for growing the maize, actually, we need to have the well-drained soil. That should be medium deep soil, or the heavy soil also will do, but the drainage is very important. It should have a high water holding capacity. The pH range should be 6.5 to 7.5, and salinity and alkalinity that needs to be avoided. Climate, you see, it thrives well in a warm temperature. Optimal temperature requirement is 25 to 30 degrees Celsius. Temperature above 35 degrees Celsius or below 20 degrees Celsius during the flowering and grain filling reduces the maize yield substantially. Sowing time, we know it can be grown in all three seasons: Kharif, Rabi, and summer. Kharif, actually the planting has been already started June 15 to July 15. Rabi season September 15 to October 15, and summer season basically January to February 15. Actually, drip irrigation, if we consider, so drip irrigation, as you know, it is a technology by which we apply the water. We deliver the water and nutrients as per the crop growth stages, exactly at the root zone of a crop. And we always try to maintain the field capacity or the moisture content equal to field carrying capacity entirely or throughout the growth period. So drip irrigation का है कि basically कल्पना संक्षिप्त होते हुए भी परिवर्तन, whatever the change we are getting, it's a very effective. Basically, सही जगह, सही अनुपात, सही समय पर, without any wastage, we are applying water, nutrients, as well as the pesticide, insecticide, so which can be easily applied at the root zone of the crop. So अधिक लाभ कमाने के लिए सक्षम किसान को बनाने वाली ये टेक्नोलॉजी. Basically, drip irrigation का एडवांटेज तो आप सब जानते हो. Water saving is the main advantage. Water saving means we are not reducing the water requirement of the crop, but we are exactly whatever is required at the root zone of a crop, and we avoid the wastage. Actually, that we can call as a conveyance wastage. Basically, the labor requirement is very less, so we save on the labors. Fertilizer requirement, basically, whatever the fertilizer we apply, we increase the efficiency of the drip irrigation, but we are applying in the effective root zone depth only, and that as per the requirement, we can apply daily, alternate day, weekly, fortnightly. So electricity is also reduced. So it's a very easy, basically. We can have the control. It's a controlled irrigation and fertigation. So quality production is very much possible, and we can get a higher rates for that. So in a drip irrigation, basically, it is divided into three parts. One is the head control, second is the distribution system, and third one is the drip manifold. Basically, in a head control unit, we have the filtration, then we have the water meter, control valve, pressure regulator, pressure relief valve, dosing unit. Dosing is for giving the fertilizer application. It can be venturi, or it can be fertilizer tank, or it can be injection pump. So we have other valves like non-return valve, air release valve, vacuum breaker valve. Then in distribution system, we have the main, sub-main, control valve, flush valve, and other H3 equipments. In drip manifold, basically we have the drip line. It may be integral or online emitters. Then we have this, suppose it is a micro sprinklers, Grommet, start connector, nipple, end cap, barbed connectors. So these are the, actually drip irrigation system is entirely divided into this. Actually, in a drip irrigation, what's most important is the filtration. Basically, because it's the drippers, the emitters, the nozzles through which water comes out, or through which water and nutrient solution comes out. They have a very small diameter. So whatever the physical impurities are there, they actually clog the system. And when the system gets clogged, when the dripper gets clogged, then other pipelines, they just become the conveyance pipeline, and the water and nutrients will not be coming out of the dripper and will not be uniformly distributed throughout the root zone of the crop. So we use, in a primary filters, we use the hydrocyclone as well as gravel filter. In hydrocyclone, basically it works on the principle of the centrifugal force. Actually, you see, in the case of bore wells or the tube wells, if they're deep enough, then we get a small sand out of that. And the sand particles now that needs to be deposited at the base, and actually the pure water that should go as filtered water should go ahead. Then another is the gravel filter. Whatever the physical impurities, जो कुछ भी होता है, मट्टी हो या including algae, that can be separated with the gravel filter or a media filter. Then secondary filters, we have the screen or disc filter. Actually, not both, but actually or. Screen filter, actually there we use the 110 mesh screen. But in this filter is a more effective. Basically, it is more 26 time filtration as compared to screen filter, because we are using the disc here. And so filtration is a very effective. The standard head unit we see, it is a water source, the electric motor or pump set, then hydrocyclone filter, then it comes gravel filter. Then for dosing, actually we can use the venturi or fertilizer injection pump. Then we have the secondary filter as a disc filter, then air valve, pressure gauges, the non-return valve will also be there. And then the water passes through main line to sub-main or to drip line. And on a drip line, there are the drippers. Basically, there is actually always a confusion in the farmers that which diameter drip line should be used, 12 millimeter or 16 millimeter or 20 millimeter. Actually, that entirely depends upon the design. But the drip irrigation system, actually the design by the manufacturer or the suppliers or the dealers is always a question mark. So if you design the system perfectly, then depending upon the drip line length, actually the diameter is decided, and that again depends upon the topography, geographical location, and actually the dimensions of your field. Suppose you are using the 12 millimeter pipeline, having the spacing of 40 centimeter and discharge of 2 LPH, then the drip line can go up to distance of 50 meter. In case of 16 mm, up to 85 meter. In case of 20 mm, it can go up to 110 meter. So considering the length of a drip line, you should decide the diameter of the dripper. Again, it will depend upon the dripper spacing and dripper discharge. Here I have taken the case of 40 centimeter into 2 LPH dripper. So another and very important part is depending upon the soil type. If you see deep soils, medium deep soils, and light soils, the water distribution, retention and distribution of water, or the wetted front which is being formed in these types of soil will be different. In case of a light soil, it will go down. In medium soil, there will be equal distribution horizontally as well as vertically. But in case of a heavy soil, the lateral distribution will be more as compared to the vertical distribution. Depending upon that, you need to select a particular dripper and the spacing. Because you see, in a light type of a soil, the actually distance between the two drippers cannot be more than 1 feet, that is 30 centimeters. And dripper discharge should be less. If dripper discharge will be more, the water will go down. So it can be 1 liter per hour. In medium type of soil, the distance between the drippers can be increased to 40 centimeter or 1.25 feet. And actually, the dripper discharge will be 2 liter per hour. In case of heavy soil, you can go up to 3 liters per hour, and discharge distance between the drippers can be up to 50 centimeters. So this needs to be very well considered while designing the system depending upon the soil type, because the soil distribution and retention properties of different types of soil will be altogether different. Then you see dripper. Actually, dripper is the most important component of the irrigation system, because the filtration will do the filtration, water will flow to main line to sub-main line. But dripper is a component through which water and nutrients will be coming at the root zone of the crop, because of which the crop growth will be perfect. So actually, the dripper discharge should be always less. Netafim Irrigation Company, actually, which is established in Israel long back. Okay, so in 1965. So we have almost covered 61 years. We have completed 61 years. This is the oldest company, #1 irrigation company in the world. We have developed the first dripper that was known as a blast dripper. So Simcha Blast was the scientist who has developed the first dripper. That's why his dripper was named as a blast dripper, and he was connected with the Netafim. Actually, here I have given the example. Suppose we use the 2 liter per hour dripper and 4 liter per hour dripper. How 2 liter per hour dripper is a beneficial? You see, dripper distance is 40 centimeter. The distance between the two drip lines will be 1.5 meter. Crop, you can take any crop, whether it is a maize or vegetable or cotton. And suppose area is 1.5 acre. Then the required drip line will be 4,000 meters. As the dripper spacing is 40 centimeter, number of drippers will be 10,000. Discharge with the 10,000 drippers with the 2 LPH will be 20,000 liter per hour. But with the 4 liters, it will be 40,000 liter. But actually, you see, the dripper, the discharge of a pump, the pump discharge is only 20,000 liter. So water requirement is 30,000 liter. So in case of 2 liters per hour dripper, the timing or the period or the duration to operate the drip irrigation system will be 90 minutes. But here in case of with 4 liter dripper, it will be 45 minutes. But here wall will be only one. My entire 1.5 acre of farm will be irrigated at once. But in case of 4 liter per hour dripper, we need to make 2 parts. So there will be 2 walls. Although the duration will remain same, because first 45 minutes will be for half of the area, and then another 45 minutes we need to give remaining half of the area. So drip line length will be more when we are using 2 liter per hour dripper. It will be 75 meter, while in case of 4 liter, it will be only 50 meters. So requirement of the PVC will be reduced by 15% with the low discharge. So if fertilizer efficiency will be more. So main and sub-main of the PVC or the trench, whatever required, will be less in case of 2 liters per hour. And it will give the uniformity. It will give the more desired distribution of the waterfront in the soil. So Netafim basically is known for the drippers. Actually, we have invented the first dripper in the world. So Irish dripper, basically, it is an injection molded dripper having a wide flow path, and it has been manufactured with a high density polyethylene. So actually, Netafim's peculiarity is that in a dripper there is a turbulence is created. Turbulence technology is there, and as you know, because of the turbulence, so whatever the impurities come in the dripper, that will be flown away with the water, and dripper will not get clogged. Another and very important thing is that, you see, although we are filtering the water, so through gravel filter as well as this filter, then also if some of the impurities or any small particle comes with the water, so every Netafim dripper, that is Irish dripper, has a filter over there. In a dripper, every dripper has a filter. So that will again filter, and only the filtered water will only go through the system, because of which the clogging will be less. And another very important thing I wanted to tell, Netafim has a patented technology. You'll be surprised to note 150 patents of the Netafim are there, 100 are in a process. So another dripper is a very important dripper, that is a dripping PC, pressure component dripper, we call it the anti-siphon. Basically, this can be used in an undulated land. If there is an elevation difference from 5 meter to 25 meter, then also this dripper gives the uniformity in discharge. As you all might be knowing, the uniformity depends upon the exponent. The equation you might be knowing, Q is equal to K into P raised to X. As the pressure raised to X is the exponent. And exponent here is a 0, because of which there is a uniformity throughout the field. Then we are actually, you see the pressure compensating or the array drippers, drip lines, they are eligible for the subsidy, government subsidy program. But every farmer may not be eligible because he has taken the drip irrigation system initially on the subsidy. And suppose he wanted to increase his area, it cannot go beyond 5 hectares. So if he has a more area, then he can go for the low wall thickness streamline X. So that type of drip lines are also available with the NETAP. So NETAP basically is the #1 drip irrigation company. It has started its working, established in 1965. So we have the, what we can say, it's a basically Israeli technology. So what's more important is उत्कृष्ट आर्थिक रूप से सही डिजाइन हम बनाते हैं. Design is the base actually. It's a foundation. So quality products are there. We give the before and after sales service. Quality products are there. Most important is that this is the people like me. I'm in the NETAP. I am providing the agronomical support to the farming community, where the agronomists throughout India, basically, they're providing the support. They're providing the support regarding starting from soil preparation till harvesting to the farmers. That may be direct or indirect support, or digital support is now available on the social media. Then we give in the right prices, appropriate prices, we can say. And we have prepared so many success stories in every crop, whether it's sugarcane or banana or cotton or maize. So we have created success stories, and those success stories are available to all the farming community, and they can visit our website and they can refer to these success stories from the farmers' mouth. Then another thing that we have developed is we have started the manufacturing. Actually, we have 2 manufacturing units. One is at Baroda. Baroda, we have 2 factories, and another is at Chennai. Chennai, we have 1 factory in India, NETAP in India. And actually, we have developed the FlexNet. FlexNet is an alternative for the main lines, sub-main lines, or water which we can go to conveyance. Suppose some of the farmers, they bring the water from water source to the field, and they give the water in a furrows or in a basin or in a so actually for that purpose, for conveyance pipe, FlexNet is a pipe. एक बहुत ही बढ़िया पाइप है, वजन में हल्का है, स्टोरेज इज वेरी इजी, द ट्रांसपोर्टेशन इज वेरी इजी, ट्रेंचिंग की जरूरत नहीं, इसके ऊपर अल्ट्रावायलेट रेन का कोई परिणाम नहीं होता. और अ फार्मर एक्चुअली ही कैन टेक द FlexNet with a small filter and he can install his system on his own. Within 2 hours, he can install the system and start the irrigation to his crop. So we have the portable drip kit also for half acre, for 1 acre. So that box farmer can take and install the drip irrigation system himself under the guidance of our supervisors, technicians, or the sales engineers, or the dealers also. We have the FlexNet sprinkler seat also. So ड्रिप बेहतर है, फसल जोरदार आती है, ड्रिप अगर अच्छा है. ड्रिप में सबसे इंपॉर्टेंट क्या है? यूनिफॉर्मिटी इन वाटर डिस्ट्रीब्यूशन एंड न्यूट्रिएंट डिस्ट्रीब्यूशन. सभी फसलों के लिए 100 से ज्यादा means we are using the drip irrigation system for the rice in Tamil Nadu area on about 700 hectares. So उपज में वृद्धि बहुत ही होती है. It's a relative basically. Fertilizers में कमी लगती है. So it can be about 30%. So ROI basically 0.5 से 3 साल तक रहता है, depending upon the crop. So लेबर सेविंग होता है, इलेक्ट्रिसिटी सेविंग होता है, और दूसरी बात प्रोडक्टिविटी इंप्रूवमेंट होती है और क्वालिटी इंप्रूवमेंट होती है. So actually NETAP basically it's a #1 company. Our market share is more than 30%, friends. This is very important. Actually, the second company has a market share of 10%. So this is more than 10%. We have 17 manufacturing plants all over the globe. We have 29 subsidiaries like NETAP in India, NETAP in China, NETAP in Russia, NETAP in USA. Our headquarters is there in Israel. So more than 6,000 employees now. We are working more than 110 countries. We have more than 1 billion sales every year. So this is in general about the NETAP. So when you come to the maize, in maize actually you see what we are recommending for the drip irrigation is the paired row planting. In a paired row planting, distance between the 2 drip lines, or what we can say center to center distance in the paired row is 4 to 5 feet, depending upon the soil type. If soil is a heavy or a deep black cotton soil, we can go up to 5 feet distance. Row spacing within the paired row pair is 40 centimeter, and plant sensing is a 30 centimeter. That is with what our experience we are recommending to the farmer. This is how it can be seen. This is the one pair, and the another pair. Distance between the two rows in a pair is 40 centimeter. And actually, we can use the plastic mulch also. Drip irrigation is also there. And distance between the actually two drip lines is 4 to 5 feet. Or at the center of the rows, it will be 4 to 5 feet. This is how the layout. And this is how, see, it's a very clean, neat cultivation. So fertilizers or the water is exactly given at the root zone of the crop. No wastage, no weeds. So easy management, mechanization is possible. This is what we can do under drip irrigation for the crop like maize. Now, as you all know, the growth stages of the crop is the germination, vegetative growth, then finally tasseling, scaling, grain filling, maturity. So it is up to 110 to 120 days. So actually, these are the growth stages, as you all know. I think operation is very important. That can be easily done with the equipments in case of a drip irrigated, a paved road drip irrigated plot. This is at the center. Now you can see here the growth of a maize. Actually, this is very important. This happens with the drip irrigation. But irrigation management is a very important for crop like a sugarcane because it's a vegetative crop. Means its growth is more, biomass production is more, and actually it requires about 2 to 4.5 millimeter water per day. That is in depth. Into area gives the volume. Daily water requirement per acre varies by growth stages as well as the climate is also very important because the climatic condition in every region they vary. Drip irrigation ensures consistent moisture, that is field capacity at the root zone of crop, approaching to the field capacity. So we do not have the stress of air, nutrients, as well as the moisture at the root zone of the crop. So moisture, air, nutrient relationship is maintained throughout the undergenesis of the crop, and that gives the best results that provides the optimum condition for growing up a maize crop. So here you can see in the picture. It's a very important percent moisture extraction that needs to be considered in every crop. That depends upon the effective root zone depth. So, 40 centimeter depth, about 70 to 80% of roots are there. So we need not to give the water below 40 centimeter. It should be only in a 1.25 feet. So that needs to be considered depending upon the crop rate while deciding the irrigation crop requirement. So actually, you see, water requirement is basically how we are calculating the water requirement. EPAN is evaporation, daily evaporation, into KPAN is the constant, into KC. KC depends upon the crop coefficient, depends upon the crop growth stage. Here I have taken one example. Water requirement per acre will be water requirement in millimeter per day into area of 1 acre, that is 4,000 square meter. Example I have taken, suppose evaporation, it is in a very hot 7 millimeters. Pan factor we are normally considering 0.7 to 0.8, but actually I have considered here 0.8. It should be on a higher side, there should not be any less water application. Crop growth stage is a 0.8. So water requirement will be 7 into 0.8 into 0.8 will be 4.48 millimeters. And if you convert into the volume, it will be 17,920 liters per day per acre. And depending upon your dripper distance between the two drip lines, number of drippers per acre, and it's a discharge per hour, you can decide the operating time. And actually, for the Netafim clients, I tell it to you, we provide them the irrigation as well as the fertigation schedule individually, depending upon his planting date, depending upon his soil type, depending on his drip design. So this is very important. Actually, for example, I have given here in the germination stage up to 6 days, water requirement will be 1.3 millimeter per day, and water required will be 5,099. Early vegetative stage, it will be 7,649 liters per day per acre. Granular storage, actually it will be 10,000 liters. Cob initiation, 11,615. Grain filling and development stage, 18,576. And again, during the maturity stage, we can reduce certain water application. It will be 16,836. So based on this, actually it is a location specific because the climatic data changes, evaporation changes, because of which the EPAN value will be changing. So the evapotranspiration is very important while calculating the water requirement. So fertigation is a very important. You see now, fertigation is not a luxury. It's an essential component of the drip irrigation. On the contrary, I will tell you, fertigation is fertilizer plus irrigation, and that is what the drip irrigation is expected. Exactly at a lower rate, more frequently, exactly at the root zone of crop by maintaining the soil moisture air nutrient relationship equal to field capacity at the root zone of a crop to get a bumper production, to get a best quality of any produce, whatever you do with the drip irrigation system. Let's say in this field, it has been shown the crop is there, wetted bulb is there, in which the nutrients are equally distributed throughout the wetted front or throughout the root zone of the crop. So it will be nitrogen plus, actually I have considered the major nutrients here. We can apply the micronutrients as well as water. That is to maintain the field. So actually here you can use the venturi, or you can use the fertilizer tank. So fertilizer dosing machines are also there. We call it the net agent. Then actually that is for the automation purpose. So important is that every quantity of water, fertilizer or nutrient we are applying, that should go in the root zone of the crop, and it should be uptake should be maximum to have the maximum use efficiency. So in a drip irrigation, what happens? We can give all major micronutrients also to drip irrigation. Only they should be either in a liquid form or a water soluble, solid soluble, we can say. So in the root zone of the crop, this is the wetted how it is prepared. I have shown in the photographs, and that goes in the wetted zone. Actually, what's more important from farmer's point of view? Whatever the growth we see above the ground surface, more than that, the distribution of the roots. It's a vertical and lateral movement. At your depth of the roots, it's sprayed. It's uptake of both water and nutrients from the root zone. That's a very, very important. And for having such a effective root zone, actually the drip irrigation helps. And more important is that whatever the micronutrient we are giving in the ppm, no, they will be efficiently absorbed with the drip irrigation. And in a automation, basically we are able to monitor or control the pH of that fertilizer solution which are passing. We can we can monitor the EC, and accordingly we can manage the what we can say is a fertilizer solution, it's a concentration, it's a dosing that we can manage, and this can be automatically done. So fertilizer application, basically the fertigation schedule what we have prepared. Actually, this is netafim schedule depending upon our experiences and whatever the yield we are trying for getting higher yields. No, so this is the fertilizer. This is the fertilizer recommendation. So basal dose we are supposed to apply FIM, because you see, when maize is a soil depleting crop, because it's a production capacity high, it takes much nutrients from the soil. So farmland manure, it's very important in order to maintain the organic carbon in the soil. DAP 100 kg, the magnesium sulfate 25 kg, zinc sulfate 5 kg, and mixed micronutrient 20 kg. That you can apply as a basal dose. That we can do through soil application also. Then, so actually from 11 to 20 days, so in these 10 days, no, we are divided into the 5 parts. So 10 days actually we can give urea 40 kg, then monoammonium phosphate 10 kg, and muriate of potash, that is white colored muriate of potash 15 kg. Then next stage, 50 kg of urea, 10 kg of monoammonium phosphate, and 15 kg of muriate of potash. Then 75 kg of urea, 22.5 kg of white muriate of potash, then 50 kg of urea, 30 kg of MOP, and finally during the maturity stage, only 18 kg of muriate of potash. This is how this fertigation schedule. Now it has given the results. Means entire, actually all over India basis, we are recommending this, and actually we are getting the results of more than 30 quintal, 30, 32, 35 quintals per acre maize production. So this fertigation schedule, this is the vegetative growth. You can see there's a fantastic vegetative growth under drip irrigation. Fertigation results you can see. Actually, this is the corn initial stage as well as the crop development. In the picture, you can see these are the 2 photographs I have shown here. This is for the benefits of viewers. Then this is number of crops per plant. You can see left hand side, you can see how many crops are there per plant. This is a happy farmer who has cultivated and got a very good yield in Maharashtra. This is a detaching of a top portion of a maize for fodder after maturity. And here only the crops will be harvested. Yes, this is how we get the productivity. Now, more important is that when we are using the drip irrigation system, what's more important is the economic analysis for the maize crop under drip irrigation system. So here I consider all the components like land preparation, seed cost, planting cost, weeding cost, fertilizer application, plant protection, harvesting. And actually, so land preparation will be the same. Seed cost will be also same. Planting cost, actually that can be reduced because we are here, we are doing here at pair planting. Weeding cost because we less weeds because of low water application and focus water application or central water application exactly at the root zone crop. Fertilizer application, yes. Here actually fertilizer requirement, although I say fertilizers can be saved, but for targeted yield, we are giving the more fertilizer as compared to conventional fertilizer. Many of the farmers know they apply very less fertilizer, although the recommendation given by the universities or the research centers are high, but they are not applying those many fertilizers. Plant protection, yes. The pest and disease infestation, less under drip irrigation. Harvesting, it will be more cost under drip irrigation. Then it's a drip cost. Here actually I have considered 50,000 rupees cost. Now it's a drip irrigation cost. Although farmers are getting 80-90% of subsidy, but here I have considered the original cost. That I have divided into 7 years because 7 years is the minimum period considered for the ISI approved or subsidized drip irrigation system. So for 7 years, it will be 7,150 per year or per crop season, we can say. The total cost of a drip, including drip, will be 42,150 per acre, while under conventional irrigation, it will be less, 35,500. But the yield difference is more. Actually, in some of the cases, we have taken thousands of plots, but we got that 1.9 quintals, 1.9 tons per acre was the yield under conventional. Well, in drip irrigation, I have said up to 35 quintals or 3.2 average I have taken. Average market rate now the rates are less. I have considered 2,500 only per quintal. So it comes per ton into 25,000. So gross return to farmer on a maize under conventional irrigation system will be 47,500 rupees per acre. While under drip irrigation, it will be 80,000. So net returns to a farmer under conventional irrigation will be very less. There will be only 12,000 rupees. But under drip irrigation, it can be 37,850 within period of 4 months. So BC ratio if work out, it comes 1.90 under drip irrigation. Actually, if you consider the subsidized cost for the drip irrigation, it will be very less. Again, the benefit cost ratio will increase, but it is 1.34 under conventional and under drip irrigation will be 1.90. Friends, drip irrigation in maize increases the yield minimum 40%. Actually, that can be double also in some of the cases. Saves the water more than 50% and improves the profitability. We get a very good quality produce. Proper soil, water, and nutrient management are key to success, which is very much possible under drip irrigation as compared to any other system, whether it's sprinkler or conventional. Adoption of modern practices ensures sustainable maize production over a period of time. This is very important. Friends, this was in short about the maize cultivation under drip irrigation, its irrigation and fertigation management. And these were the techniques actually through which we can get a higher productivity, good quality produce. So this is in short about my present. Hope you all have liked my presentation. So what we'll be doing now, I'll stop sharing and I'll be joining the meeting again. If there are any questions, I'll be more than happy to answer your queries, answer your question. So I say under drip irrigation, we have tried Pedro method of planting. Then we got a very good vegetative growth. We got very good crops, and actually the weight of crops per unit weight was also more under drip irrigation, and more number of crops were also there. So this is how actually I have tried to cover. Thank you for the patient listening, and thank you organizers for giving an opportunity to come over this platform and give the presentation from my side. Thank you very much.
Thank you so much, sir. If anyone has a question that you want to ask to Deshmukh sir, then you can ask. You can write in the chat box also the questions.
Sir, was it okay actually? Whatever is required by you actually?
Yes, very much, sir. It was excellent, sir.
You don't speak a single word actually. I do not know because I am coming first time on this platform. And the another thing is having a time limit for that reason.
A time limit was just for, sir, if the presentation is good, sir, there is no time limit, sir. So you can extend it, sir. You can discuss more. There is no issue, sir.
If there are questions, any interaction, we can have a more time.
So anyone has a question for sir, then you can ask. You can ask directly to sir. You can turn on your mic and you can, if anyone, किसी का अगर कोई सवाल है?
अगर कोई भी सवाल हो regarding the drip irrigation system, regarding the maize cultivation, then you can ask me. If I know the answer, I will answer immediately. Otherwise, I can personally, individually contact you. No issue.
सुनील करा सर, महाराष्ट्र में तो सर ड्रिप इरिगेशन का सर जरूरत है सर, आप बताइए सर.
नहीं एक्चुअली नहीं सर, ये आपका सेंटेंस बराबर नहीं है. ड्रिप इरिगेशन का जरूरत तो ऑल ओवर इंडिया
हर जगह है सर, हर जगह है.
इट्स नॉट ओनली.
हाँ सुनील सर, आप
पानी है, नहीं, जहाँ पे ज्यादा पानी है उधर पहले जरूरत है. बिकॉज वी आर डिटोरेटिंग द सॉइल्स फर्टिलिटी एंड प्रोडक्टिविटी इज अ बिग क्वेश्चन मार्क with our conventional irrigation system. We are not irrigating the crop, we are flooding the plots, and we are adding the salts in that. Salinity is a major problem. pH has been increased, EC has been increased. So salinity and alkalinity is a major problem in India under conventionally irrigated fields.
Yes sir. Noted sir. अगर किसी का सवाल नहीं है तो जरूर सर है क्या? जरूर सर भी नहीं है यार. If there is no question, sir, thank you so much for your excellent presentation, sir. The presentation was very practical and it was very quite informative, sir. And thank you so much, sir. And we will try to contact you for other lectures in our in other training sessions, sir. And thank you so much, sir, once again, sir.
Thank you very much, sir. Our services basically from the NetApp Irrigation, I assure you, we are the agronomists who are experts in different crops. We are there in the field for last, actually my experience is more than 39 years, sir. I started my job in February 1987 after completing my post-graduation from IIT-Kharagpur. Although I am an engineer, I am heading the extension department. I was looking after in Vasantara Extension, and now also my job is extension. I am providing the knowledge to the farmers, and there is a knowledge transfer. So for any moment of a time, I was very much associated with the ICR for different projects also when I was there in the institute, when I was working as a scientist, and I worked as a scientist. Means I started scientist, senior scientist, then I became the principal scientist. So I know what help we can provide to the research people in order to have the effective extension to the farming community. So I assure you all the support.
Yes, sir. Yes, sir. Thank you so much, sir. Dr. Mani, someone is asking Arun sir's number. Can we share your number, sir?
Yes, my number actually I can tell it to you on a phone or I can put it in a chat also. My
Yes,
number
sir.
is 954545. You can put it in the chat 954545. 954545 6902.
I think Dr. Meena, I think you got sir's number, and Dr. Manish will also post this sir number in the chat also. I will ask Manish to post sir's number.
Yes.
And I think RK Meena has got your number, sir. Thank you. He's saying thank you so much, sir.
Thank you,
so
sir.
much.
Thank you. Whether I can leave whether I can leave the meeting actually because I have some.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. You can. You can. Thank you so much, sir.
Okay,
Uh,
thank you.
okay.
Anytime actually my support is required, I am there available 24
Yes, sir.
hours.
Yes, sir. Sure, sure, sir. We will take your service again, sir.
And basically I'm a sugarcane expert, but I can speak on so many crops because I am in a private company now. I'm a
Yes, sir.
techno-commercial agronomist.
Thank you
Yes.
so much, sir.
Okay, thank you.
Okay.
Thanks.
Okay. Narendra sir has joined or what? Then I think sir has joined. नरेंद्र सर
हेलो
सर आप ज्वाइन कर लिया ना
हाँ गुड इवनिंग डॉक्टर
गुड इवनिंग सर so shall we start sir
I share my presentation
so our next speaker is Dr. Narendra Singh, Assistant Professor Agronomy at Hisar CCS Haryana Agriculture University, and he is currently posted at Regional Research Station Karnal, Haryana. And sir is part of our network also. He is an accomplished agronomist with expertise in maize agronomy and irrigation management and weed management. And sir research mainly focus on efficient crop management practices that focuses on improve water use efficiency, conserve irrigation water, enhance maize productivity under diverse agroclimatic conditions. Today, sir will deliver his lectures on irrigation scheduling and saving water through drip irrigations. So, sir, on behalf of all the participants, sir, I invite you to deliver the lectures. Over to you, sir.
Thank you, Dr. Roman. Very good evening to all the participants. As the title given to me for the training is irrigation scheduling and water saving through drip irrigation. A lot of things has been already discussed by Dr. Arun about drip irrigation. So I am starting with this water scheduling, how irrigation is required and what is the need of irrigation. The basic need of irrigation is to fulfill the requirement of the crop. And the question raised that and when and how much irrigation we have to apply. So scheduling is required at that times because the scheduling proper water scheduling is not to be done. There is a a large harm to the crop maybe occurs, or due to that wilting or excess is water logging is there. So water scheduling is required, and we have to measure how much water is given to the crop at which stage. It is also essential. And what new technology we have needed for scheduling irrigation, that is various water meters or the moisture meter is available now, so we can scheduling the crop properly. So there are irrigation method that we look forward that the irrigation will be given. So first is generally our more practical is surface irrigation. So in surface irrigation we have this dead level basins. In dead level basins we have level field, and the first principle of irrigation on the level field is first we go for the laser leveling is must required, as a gradient is required for irrigation, and the graded borders. And as we seen in the fields that in general we have makes the bunds to move the irrigated water in particular way to disperse the all the irrigation water in all the field boundaries. So graded border is required, and graded furrow with surge furrow also required to remove the excess water from the field. So this characteristic for the uniform land grading, reduce runoff or control application. This require must. Then another irrigation methods as discussed by Dr. Arun earlier, that is pressurized irrigation, that we have a proper water irrigation system is there. We have released from the this drip system or sprinkler or micro irrigation through pressure, and there is a lateral lines is there, so water is distributed through the lines. So low flow required, good filtration is required, as already discussed. Reduced application losses is there, reduced runoff there is there, control application is there. So why water scheduling needed? That irrigation in global level we have 75% of water is used through irrigations, and irrigated land is 12%, and total areable land is 34%. That will be water distributed through canals, underground waters, or rainfall, or another way. Scheduling is the most controllable element in the soil water. The soil water relationship is required. Then irrigation scheduling, what is the criteria that we can soil water regime, then climatological, then plant indices. And soil water regimes, we have the field appearance, we have take the soil in our hand and adjust, or whether we have seen the what is the soil moisture tension is there. So in climatological, there is a pan evaporation or IWCP ratio is there. And plant indices, as the in generally we have go for the this visual symptom, plant population, or this water potential, temperature, or the critical growth period as required by the plant. We have scheduling the irrigation. Then scheduling irrigation is the crop is the advantage of scheduling, that farmer can rotate among the various field to minimize the crop water stress. It reduces the farmer cost or labor cost. Judicial use of water is also required in scheduling irrigation. Low water, the fertilizer cost also low in the scheduling irrigation, and increasing net return by increasing the crop yield and the crop quality. Minimize the water logging, as we seen in sodic soil or saline soil. If we have give use water, then there is a water logging problem is there, and there is a less growth in sodic soil or saline soil is there. This is the situation, is the our field situation in Karnal. We have the farm that if we not go for this laser leveling or irregular irrigation or rainfall is there, so this situation may occur due to because in sodic soil there is a hard pan is there, and only 10 to 15 centimeter layer is only used for the cultivation. So in this situation, as the hard pan resists the water to percolate in ground, so this situation occurs. If we have not leveled the fields and there is a rainfall is heavy, or we have gave the irrigation, these situations occur, and there is a total loss of crop is there. And depletion of a soil, this is also criteria DSM. This depletion of available soil moisture. This is a moisture effective root zone depth is required. So we have generalized in various way. This is the guidelines. So for different texture of soil, we have different appearance, or in coarse texture soil, if we go for this, the soil bound in the hand. If there is a loamy sand soil, this is bound in the hand. If in coarse above, there is above field at field condition, it is nicking like we have go for this make chapatis and atta is there. For this like of squeezing is there. So in sandy loam soil, in silt loam soil, free water can be squeezed out. If we take in our hand, that is squeezed out. And water from in clay loam soils, the free water from the surface, water will be stagnant on the surface in pedal conditions, as we see. These are the methods. Hand filling method. We have described that is how much is water is in the soil. For various crop, we have different optimum DSM levels of various crop. For maize, it is 20 to 50% DSM in Hyderabad conditions, or in heavy soils. In Haryana, is different in 20 to 30%. In different crops, there is a different DSM levels. This is the threshold moisture tension value for scheduling irrigation. So these are the different critical soil moisture tension for different crops. Then climatological approach, we are already I described that this pan evaporation, or this pan evaporation technology or climatological approaches have the. Then IWCP ratio, we also how much water irrigate and what is the cumulative pan evaporation is there. So these are the techniques. This is the pan evaporation, that how much water is evaporated and how much we have to give for the irrigation. Then plant indices, then that there is a wilting is there, drooping is there, curling is there, rolling is there. There is a discoloration of the foliage also occur in water stress condition, if excess water is there, or is there low water is there. These are the situations. If we go for this less water, then this wilting will take place. As we go for the excess rainfall after in early vegetative phase, the drooping of leaves takes place, and if more than one day there is a stagnation of water is maize crop, then there is a declining of yellowing is there, necrosis there. After 1 or 2 days, there is a total mortality is there. And the soil sand mini plot technique also modified, also has a technique. We can understand how much plant is there and how much water is taken by the plants, and how much we irrigate for the. And plant population also indicates if the plant population is higher, then there is a evapotranspiration is higher, as well as demand of water is higher. Same is the rate of growth. If trigger pressure is there, then the vegetative phase, there is a more requirement of water, and relative water content also. These are some indicator plants also. There is maize and sunflower as the indicator plant, which critically show that the water. In concern of the maize scheduling, these are the as we discuss in Kharif season, the water requirement is near about 500 to 600 or 800 meter, depend on the rainfall is required. As we go for this spring season, the water requirement is much higher. It is near about 200 mm is there, because the crop period is larger, near about 120 days, and there is a very less rainfall is there. Crop there is much higher evapotranspiration is there, so plant need much water. And in an initial phase, in month of February, March, there is a requirement of less irrigation, but in month of April, May, or up to June, there is a high requirement is there. So farmers go for 15 to 16 irrigation are given to the crop. So there is a very high amount of uh, uh, depletion of this groundwater in. So government of Haryana and Punjab also a decision to ban the spring maize crop maybe. So so for that we have go for the proper scheduling of irrigation and technologies which are best for saving of water, like this bed planting method, pneumatic planting, zero tillage, then this drip irrigation system, sprinkler. So we have go for the that less water required for these crop. This is the situation. This is my experiment in the field, that we have clearly seen that the crop is shown on this 7th of February 226. As we clearly seen that this is the drip irrigated crop. The crop mature earlier, 1 week earlier, and it's required near about 700 to 800 water is required in spring season. In pneumatic plant, there is pneumatic planting showing, as well as drip irrigation is on the bed. So you can clearly, this one is the conventional on the crop is shown in the ridges. So this crop require much water, near about 200 mm, or near about 30 to 35 to 40% is much water. And crop uh, crop uh, crop has very less output, near about 20% less production is there in conventional farming. So we can promote this drip irrigation in spring season. That will lead to higher higher the productivity and less water required in this situation. This is the situation as the farmer do in spring season. They totally immerse the crop with the irrigation to get maximum production, but it is total failure. So we have encourages the farmer to shown the crop with pneumatic planter, because with pneumatic planter shown the maize crop on the field moisture. So there is no need to sow the crop in dry condition. The crop, the, uh, the maize seeds germinate in the field moisture conditions, and we have saved 1 to 2 irrigation initially. And this is the practice. And this is my experiment we have conducting from last 2 year, and we have, you can clearly seen that there is a optimum irrigation is there, and we save much water in these conditions. Only required irrigation is given to the crop, and this is much, because in spring the root profile of the plant is in the upper section, and it required all the nutrients through drip or this irrigation in the upper layer. So there is he not need to go for the deeper layers, and very less water required in drip irrigation. This is the principle to use high water use efficiency in drip irrigation, and this also discussed earlier. This is the our unit at regional station Karnal. This is the new one model is there for drip irrigation. This is very simple techniques in this. So for this we have planned a accurate trial on that, for how much water is saved from this drip system. So we can clearly see that in the furrow irrigation with 100% RDF, the yield is near about 99 to 99 quintal, per hectare is there, and the irrigation required is 2602 and water productivity is 3.8 kg per meter. So as compared to this drip irrigation with 100 RDF with fertigation, there is 110 kg per hectare yield is there, and irrigation applied is much lesser as compared to this near about 25 to 30% less irrigation is required through drip irrigation, and what productivity is higher as compared to this furrow irrigation. So as we go for this drip irrigation system in the field, or we can popularize this technology with this pneumatic planter sowing on beds or this drip irrigation. The farmer can save near about 30 to 35% irrigation. And as farmer go for spring maize cultivation, the crop is harvested near about in the month of June, and farmer go for the paddy cultivation. So whether we go for this drip irrigation, he can easily manage the crop before the onset of monsoon, and he will take the higher production in maize, and also go for this paddy cultivation. Whether he go for the late and go for this conventional irrigation system, he has a much higher moisture in the grain, and uh, the market price is less as because the market requires 50% moisture in grain, but the farmers go for the late sowing or this conventional sowing. There is a near about 20 to 25 to 30% moisture there. There is a less demand for that for this grain. This is the situation. You can see in the picture that the plant required only the optimum moisture required for this growth. This is already discussed. These are different type of drippers as discussed by Dr. Arun earlier. The online dripper, the PC dripper and non PC dripper is there. This is the for filtration system or fertigation unit is there. In drip system, there is a very less amount of weeds is there. As in my experiment also, there is a weed density is very less as compared to this ridge irrigation system. There is much higher weeds is there because irrigation application is very less, and it only not reaches on the beds. So there is very less amount of weeds is there. So on conclusion, if we go for the scheduling of irrigation management, we can save money, water, energy, labor, save fertilizer, protect our groundwater, minimize pest and disease problem, and improve quality and increase yield. So thank you. This is my topic because earlier the drip system is already studied to you. So I have scheduled irrigation. Thank you. If there is any question, and
थैंक यू सो मच सर। किसी का सवाल? शुभम, आप बहुत ताली बजा रहे हो। शुभम, क्वेश्चन पूछो सर से। शुभम ताली बजा रहे सर। शुभम,
Yes, sir.
किसी सर से कोई क्वेश्चन?
No, sir. No any question. I
ठीक है।
already work with sir.
ये मेरे से पूछते रहते हैं।
और किसी का सवाल है तो सर से पूछ सकते हैं। और अगर किसी का अगर सवाल नहीं तो सर बहुत बहुत धन्यवाद सर, आपने बहुत अच्छे से समझाया सर। और हम आपके साथ कोई दूसरे ट्रेनिंग प्रोग्राम में भी सर हम आपसे मदद लेते रहेंगे। और ये है कि सर आप एग्रिप में भी हो तो सर आपसे हम तो कांटेक्ट करते रहते हैं। तो बाकी लोगों को सर का जो हिसार सेंटर जो है हमारे एग्रिप सेंटर का वन ऑफ द बेस्ट सेंटर है सर। आप लोग भी जो नियर बाय है वो भी आप विजिट कर सकते हैं सर के सेंटर में। बहुत अच्छा एक्सपेरिमेंट लगा रखा है सर ने। तो यही बात रख के सर बहुत बहुत धन्यवाद सर। थैंक यू वंस अगेन सर। थैंक यू सो मच सर।